Have you ever wondered how exactly scientists calculate the sidereal orbital periods of our system's planets? To achieve this, they use the Synodic equation linking the apparent motion of an object with Earth's movement. The mathematical calculation clearly demonstrates why Mars appears slower than the swift and scorching Mercury. Such rigorous analysis makes it possible to flawlessly reveal the true physical scales of our entire solar system.
So, when you look up at Jupiter in the night sky, it appears to come back to the same spot, a full cycle, every 399 days. And the immediate question is, well, is that it? Is that a year on Jupiter? As it turns out, our view from here on a moving Earth creates a really fascinating cosmic puzzle. And in this explainer, we're going to use some surprisingly simple mathematics to uncover the true length of Jupiter's journey around the Sun. Here's how we're going to break it down. First, we'll look at the problem from our perspective here on Earth. Then, we're going to define exactly what a true orbit is. After that, we'll walk through the actual calculation, reveal the answer, and finally, explore why this seemingly simple idea was so revolutionary in the history of science. You know, the biggest challenge for early astronomers was pretty fundamental. It's incredibly hard to get a clear view of the racetrack when you're one of the cars racing on it. Our planet's own motion really complicates everything we see out there. Right, so if you were to track Jupiter, you'd notice it takes 399 days to come back to its brightest point in our night sky, what we astronomers call opposition. You might think, great, a year on Jupiter is 399 days. But that's just not the whole story. That number is really just an illusion, an artifact created by our own planet's movement through space. This 399-day cycle actually has a specific name, the Synodic period. And I want you to think of it as a relative year. It only makes sense when you consider the intricate dance between Earth and Jupiter together. But it is not, and this is key, Jupiter's true orbit. So, to get to the real answer, we've got to be precise. We need to understand the fundamental difference between this relative year we see and a true year. Let's really break down these two critical concepts. The best way to visualize the Synodic period is to imagine the solar system as a giant racetrack. Earth is on a fast inner lane, zipping around in about 365 days. Jupiter, way out on a much longer, slower outer lane, has only moved a small fraction of its orbit in that time. So after Earth completes one lap, we have to keep going for about another month just to catch up and lap Jupiter again, to get back into that perfect alignment with it and the Sun. It's that extra catch-up time that creates the 399-day Synodic period. The Sidereal period, on the other hand, well, that's the true year. To measure this, you'd have to imagine watching the whole show from a fixed point way outside the solar system. From that stationary viewpoint, you could time exactly how long it takes Jupiter to make one full 360-degree lap around the Sun and return to the exact same spot against the backdrop of distant stars. That is the number we're actually looking for. So let's just summarize that. The apparent year we see, the Synodic period, is 399 days. It's all based on alignment. But the true year, the Sidereal period, is the real prize. The question is, how do we get from one to the other? Well, it turns out we can do it with a surprisingly elegant equation. All right, now for the really fun part, the math. We're about to see how a beautifully simple formula can take what we observe from our moving planet and turn it into a true map of the cosmos. Our approach here is going to be very methodical. First, we'll pick the right formula that describes how these orbits relate to each other. Then, we'll just rearrange it to solve for our unknown, Jupiter's true period. After that, we'll plug in the numbers we already know from observation and do the simple math to get our answer. So here are the two numbers we need to get started. We have our observed data. We know Jupiter's apparent or synodic period is 399 days. And of course, we know Earth's true or sidereal period is 365.25 days. Believe it or not, that's all the information we need. And here it is. This is the key equation that connects everything. Now, it might look a little strange written with fractions, but the idea is actually quite simple. Think of each term as an angular speed. How much of an orbit is completed per day? So 1 over s represents the relative speed we see, how quickly Earth appears to lap Jupiter. 1 over t Earth is Earth's true speed, and 1 over t is Jupiter's true speed. The equation just says that the relative speed we observe is simply the difference between Earth's faster speed and Jupiter's slower speed. Okay, so with a little bit of basic algebra, we can just shuffle this equation around to solve for the term we actually want, which is 1 over t. This term represents Jupiter's true daily speed, It's going to tell us exactly what fraction of its own orbit Jupiter covers in a single Earth day. And now we just plug in our numbers. When we subtract those two fractions, we get this incredibly small number, 0.0002315. And that's it. That's the key. What this means is that in one Earth day, Jupiter only moves that tiny, tiny fraction of its total 360-degree orbit. So, we figured out Jupiter's daily progress. Which brings us to the big question. How many of those days, how many of those tiny steps does it take to add up to one full lap around the sun? And the answer is a whopping 11.83 Earth years. To get that, we just take the reciprocal of that tiny daily fraction we found. So 1 divided by 0.0002315, which gives us about 4,320 days. And when you divide that by 365, you get almost 12 Earth years. To really put that into perspective, think about this. If you could live on Jupiter, you'd only get to celebrate one birthday for every 12 that pass by here on Earth. I suppose you'd get fewer gifts, but I imagine they'd be pretty grand. Now, this is so much more than just a neat math trick. Back in the 16th century, this exact kind of calculation completely changed our understanding of the universe. And it was all thanks to one man. Of course, I'm talking about Nicholas Copernicus. And this type of calculation, this was his key to unlocking the whole system. You see, before him, the solar system was this messy collection of mystical spheres and overly complicated paths. But by using this method to find the true sidereal period for every known planet, he could finally figure out their correct order and their relative distances from the sun. For the very first time in history, someone was able to draw a true, scaled map of our solar system, all based on observation and mathematics, not just on ancient belief. So in the end, that simple question we started with, what is the true year of Jupiter? It leads us to a really profound conclusion. It shows us that by patiently observing the sky and applying the clean, undeniable logic of mathematics, we can see past the illusions of our own perspective and discover the real, elegant structure of our solar system.
Thank you, friends. Strive for understanding and become wiser. See you soon.